When you look at this question, what comes to mind? Sometimes we look at questions and get a little bit overwhelmed with all of the little details, but your brain works in this really interesting way where like it's got all of this knowledge in it, right? But different pieces of knowledge are connected to each other. So if you start to just think about one of the parts of a question, this question or any question, it will start to fire up that part of your brain and everything connected to it, and it's easier to remember other details. So if you can, but if we get overwhelmed, we shut right down. So what's one thing that you think of when you see this, Ayla? Nice. So right away I'm thinking exact value means special triangles. That's got to be one of the angles in the special triangles. And so I got to figure out which. Good. John? Nice. So it's a reciprocal, but I know it's 1 over cos. And then hopefully your brain starts to make connections and figure out exactly how to do it. So we can start with this. Secant of 5 pi over 4. Some people would do this. Equals cos of 4 over 5 pi. Some people would do that. Whoops, it's going to disappear on me. Cos of 4 over 5 pi. But no, that's not what a reciprocal means. You never take the reciprocal of the angle. Okay? What it means is it's 1 over cos of 5 pi by 4. Now, before we move on, I want to just do a quick review of sort of radians and how you work with this stuff. Drawing these little diagrams always helps. Remember, you got to know what quadrant you're in. You got to use the cast rule to figure if it's negative. It's like you're putting on your detective hat. There's not a step-by-step process to solve these. It's you're pulling in all kinds of little pieces of information from different sources and putting them together to form your solution. So I could count in radians, count in fractions in pi by 4s. This is going to be 1 pi by 4, 2 pi by 4, which is pi by 2. So again, that's something that I know. 3 pi by 4, 4 pi by 4, which is pi, 180. And that's a good anchor point. That pi and is equivalent. Pi radians is equivalent to 180 degrees, right? So you can replace pi with 180. Like that's one of the things that we do when we're converting. Okay, but and 4 pi over 4 is the same as 1 pi, right? So 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, and 5 pi by 4, which is what we're looking for. So we are in the third quadrant. Why do we use the cast rule? What does the cast rule tell me? Yeah, where each of the 3 primary ratios and therefore reciprocal ratios is positive or negative, right? So cosine is positive there, sine is positive there, the other ones are negative, tan is positive in the third, the other 2 are negative, they're all positive in the top quadrant. So cosine is negative in the third quadrant, which means I do another step where I go equals negative 1 over cos of the related angle, pi over 4. We're always trying to boil it down to the related angle. For 1, that's what I could put in my calculator, but for 2, and in this case, that's what's in the special triangle. But if I put 5 pi over 4 in my calculator, you could try this, you'll get a negative answer. If I put 1 pi over 4 in my calculator, I get a positive answer. So I have to put the negative sign out front to deal with that. And then I can do which of the 2 triangles is this one. Whoops, that wasn't a very good triangle, but anyway. So this is the right angle, which is pi over 2. And this is the pi over 4 and pi over 4. And they have to add up to 180, which is pi. And then you need to know the measurements, 1, 1, root 2. Those are built with Pythagorean theorem. And cosine is adjacent over hypotenuse. So it's 1 over root 2. So 1 over 1 over root 2. And then if I can do the fraction math, but by this point, if you've been getting the fraction stuff over the course of the semester, like this is where those are the fraction skills you want to just kind of know how that works out. Anyway, it's negative root 2. And yeah, your calculator would give you that, although calculators typically don't have the reciprocal functions on them, so you would need to know how to put it into your calculator. But showing the steps is likely how you're going to get full marks. It's certainly possible that we could ask some short answer questions where a question like that is worth 1 mark, and if you could do it on your calculator, then you'd get full marks. But it's certainly also possible that that would be a 2 or 3 mark question. You'd only get full marks if you showed your work. Showing your work would be things like showing sort of that step and that step, at least, kind of thing. Stop me if you have questions, otherwise we'll move on again. If you think you can solve this one, go ahead and do it. Something that I notice is this is similar to the first question, but the first question gave me the angle. In this case, I'm looking for the angle. One of the tricky things about all of this trigonometry, the angles in standard position stuff, is people get confused about which question is which, right? And you kind of know the steps involved in all of them, but you mix them up. So if you tried to solve this question like the last one, it's gonna be a disaster. If I was doing an angles and standard position question and I was stuck, I would think, well, it usually has something to do with the related angle. Like, how do I find that? We had to find it in the last example. We weren't given the related angle. We had to find it. And we'll have to do the same in this one, but it'll be different. The way that we find it will be different, right? But you still have to find the related angle. So again, I'm going to jot down some information. One thing that's interesting about cotangent, tangent is opposite over adjacent, so cotangent is adjacent over opposite. Whoop, what odd, I don't know why I wrote that. And what does the 1 over root 3 tell me? John? Yeah, that we're using special triangle, it's an exact value, and which of the 2 special triangles, so the other one, not the same one we used in the last example, the other one. Again, this is the right angle pi by 2, and when I look at it, I want to draw this one such that one of the side lengths is longer than the other. And then I have to get my angles in the right spots. And sometimes this is, and I remember on the test, this is where some people made the mistake because 6 is bigger, so people put that at the bigger angle. And the bigger angle is 60, but it's like pi over 6, right? So your brain just kind of fools you and you get those in the wrong spot. But pi by 6 is a smaller number than pi by 3. And so it's the smaller angle. It's the 30-degree angle. Pi by 3 is the 60-degree angle. Again, 180 divided by 3 is 60. That's a 60-degree angle. So all of that knowledge can be useful to tie in. And then I have to label the side lengths. So it's 1, 2, and square root of 3. You either memorize that or you understand how this triangle was built so that you can come up with those numbers. Root 3 is smaller than 2. You could use your calculator to check that. And you would know which one's the smallest side. The hypotenuse is obviously the biggest side, so you could order them like that. I don't know. Different people probably have different strategies for how they build these triangles. And then we also need the cast rule. At this point, I could find the related angle. Actually, let's go ahead and do that. So theta related. Remember, you have to put that little r to say that it's theta related. 1 over root 3, when it's adjacent over hypotenuse, means my related angle is pi over 3. And then I'm going to, again, use cast. What does cast help me with this time? Well, the solution, 1 over root 3, is positive. I know that because there's no negative sign in front of it. That's a positive number. So that means I must be in a positive quadrant. And in this case, there's no way to narrow it down further. So we have 2 possible answers that will give me, the cotangent of those 2 angles will give me 1 over root 3. Right? So I've got 2 possible answers. One of them's in quadrant 1. So that's just equal to the related angle. And the other is in quadrant 3. And quadrant 3, we use our little formula. It's pi plus theta related, which is pi plus pi by 3, which is 3 pi by 3, which is 4, plus 1 pi by 3, which is 4 pi by 3. Any questions about that? So we've got 2 answers, 1, 2. Okay, next question is find the equation of this graph. This is closely related to graphing, obviously. I'll give you a few minutes to get started, or a minute or 2 to get started on that. It's useful to have a focus again, like something that you're working towards instead of just staring at a graph. What are you trying to do in this case? Ultimately find the equation, but the transformations. Yeah. What else? So if I think about the transformations, that's going to allow me to find the value of A, K, C, and D. And A, K, C, and D are the variables you need to plug into the function. And then what's the other little thing? Like, how can I think about the transformations in a different way? Those 5 key questions that we talk about. And those are all different ways of saying the same thing, but ultimately you want to get the A, K, C, and D. So try to, even if you can't get them all, get a couple of them, see what you can do. one of the first things that jumps out, obviously this is sine. That goes without saying, but there are some properties of sine that we want to know that's going to help us figure out these details. So where are those 5 critical points? And 3 of them are on the 0 line. And sine starts on the 0 line and ends on the 0 line. And the 0 line tells me the D value, the vertical shift. You don't have to do these in any particular order, obviously, so why not start with that? D is 1. And the phase shift is the same as the C value. So this is so I have to look at the scale. So this is pi by 2. If I cut that in half, I get pi by 4. So that's 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, which is pi, which makes sense, 5 pi by 4, 6 pi by 4. You don't need to do this, obviously, but it's useful to sort of remind us about how this graphing and scale stuff works. 6 pi by 4 is the same as 3 pi by 2, right? So all of this works. So let's go back to here. So the start was 3 pi by 4. So my C value is 3 pi by 4. When I put it in, it's minus C. So when I put it into the function, into the equation, it's going to be x minus 3 pi by 4, but the C value itself is positive. What do we have left? A. There's a couple different ways you can find A. You can find the distance between the 0 line and the max. So 1 to 4 is up 3. Or you can do the max minus the min, right? And then divide by 2. So if I do 4 minus negative 2 and divide that by 2, that's 4 plus 2, which is 6 divided by 2 is 3. It's useful. Probably most people would do it the first way. I don't know, maybe that's not true, but I feel like the first way is a little bit easier. It's just kind of you get it from the graph. You just do it by inspection. But knowing that the 0 line is halfway between the max and the min can be useful. Sometimes people find it easier to find the max and the min. I don't know. Okay, and then the last one is the K value. So first of all, I'm going to find the period. And the period is the stop minus the start. So where it stops, this is 8 pi by 4, 9 pi by 4, 10 pi by 4. It stops at 11 pi by 4. Minus the start, which was 3 pi by 4. 11 minus 3 is 8 pi by 4, which is 2 pi. Which means there is no change in period, but if there were, how do you find it? Well, it's 2 pi over the period, so 2 pi over 2 pi, which is just 1, so K is 1. So now we're going to write it. There's no reflection. So it's y equals a sine k x minus c plus d, which in this case works out to y equals 3 sine of x minus 3 pi over 4 plus 1. And then next, which is very similar, it's actually a very similar question for some reason, but anyway, graph that function. So go ahead and do that. You've got a grid on the handout that you could use. It's a bit small, but I think you can probably make it work. Or you could use your own graph paper, obviously, if you want. You don't have to use the 5 key questions, but the 5 key questions are a really focused way of getting all the information you need to graph out of the equation. If you don't use the 5 key questions, then you have to come up with that information anyway, basically. But you just maybe brute force it. Maybe you have a different order you like to do it. Like, not everybody uses the 5 key questions, but it really is the most straightforward, easy way, and it gives you purpose. That's part of a lot of people have a tricky time in math just because they don't know where to start or they don't have the steps, and that's what the 5 key questions can do. Regardless of how you do it, you should certainly show work, because if you end up getting it wrong, if your scale doesn't work out in the end or something like that, I mean, even if you're confident going in, you've all experienced that confidence and then something just doesn't work, like, and your brain sometimes latches on to one idea and you can't pull yourself away from it, you know what I mean? Like, so if you show some work, you at least get part marks. If you show no work and you just try to graph it, your graph is wrong, you might get 0. So be very careful of that. So that's what I have so far. Again, if you need this slower or a bigger review of this, then all the videos are still available online. You can go back. Everything's in the Google Classroom. You can go back to this day and look at it more carefully, or just look at the notes for exactly what the questions are. But question 1 is, what's the 0 line? That comes from the D value. And then we use the amplitude, which is 3, not -3. Amplitude is always positive. But what we're using that for is to find the max and the min. So from the 0 line, I go up 3 to the max and down 3 to the min, right? So that's why I need the 0 line first, and then I need the amplitude so that I can find the max and the min. Those are the points that we need because they're 2 of the critical points. Whether it's sine or cosine, this process is all the same. Question 3 is the start, and that's just the C value. It's x plus pi by 6, so C is negative pi by 6. That's a shift to the left. Then we find the period, which is 2 pi over the k value. K is a half, so it's 2 pi divided by a half. Again, we know that a half means that we have a stretch. horizontal stretch. So my period should be getting bigger. If one graph happened in this amount of space, if one cycle, happened in this amount of space, I'm going to stretch that to happen in a bigger space, so my period needs to be bigger. So I'm dividing by half, makes it bigger, so it's 4 pi. And then the last question is the stop, which is where we start plus the period. Do a bit of fraction math. 23 pi by 6, a little bit nasty, but that's what happens. And then, like I said before, it really should be the 7 key questions. I don't know why we stuffed up 5. Because then I have to figure out what's the distance between the critical points, or maybe this is only one extra question, I don't know. But what's the distance between critical points? I take the period and I divide it into quarters. And that seems counterintuitive to some people, but 1, 2, 3, 4. From the start, there's 4 quarters of the graph because there's 4 more points. That's how that works out, right? So I take my period, which is 4 pi, and divide by 4, and I get pi. And then the reason why we're doing that is because it's good to know where they fall, but I also need to figure out my x scale. Now, I know I think a lot of people just kind of, Mr. Gardner has a whole different way that he likes to work with the scale. So there are other ways of coming up with a scale, okay? And if you remember back at this point, it can be tricky. Some people never get it really, but you've got to play with it enough to get to a point where you can figure out a way to get a scale. So one of the ways is I take the distance between critical points and I start dividing it by things. And the thing I divide it by is will end up being the number of squares between critical points, which makes it really easy to graph if you know that. The problem is in this case, when I divide this by 3, that doesn't match where it starts. So what I would do if I chose pi by 3, it'd be 1 pi by 3, 2 pi by 3, 3 pi by 3, which is pi, but pi by 6 isn't on there. It's not a point on that scale. In that case, pi by 6 would be halfway between. So that's not going to work. Okay, so that one's no good. So then I could we might just start trying other numbers. You could try pi by 2. That's not going to work. You could try pi by 4. That's also not going to work. And it turns out, and people might have guessed this in the beginning, pi by 6 works. And I know it works because it is the start. So pi by 6 is going to work. But what that means is I'm going to have 6 boxes between my critical points. And if you go that big, you got to make sure you have enough. Now, usually we do give you enough squares to graph that. We don't usually do more. So if you go up to pi by 12, because you could kind of cheat and just, I'll just always use pi by 12 because everything goes into that, you probably won't have enough space on your grid. And you have to be able to graph one full cycle. Like we give you enough space to do that. You got to fit one full cycle in for sure. So you can't cheat too much. But in this case, pi by 6 is what's going to work. Okay? All right. So I get 1 pi by 6. 2 pi by 6, 3 pi by 6, which is pi by 2. And then 4 pi by 6, 5 pi by 6, 6 pi by 6, which is pi. 7 pi by 6, 8 pi by 6, 9 pi by 6, which is 3 pi by 2. 10, 11, 12, which is 2 pi. 13, 14, 15 pi by 6. Divide by 3 is 5 pi by 2. 1, 2, 3, 3 pi. 1, 2, 3, 7 pi by 2. 1, 2, 3, 4 pi. And that is enough that we've now gone past where one cycle will end, so we're good. I could also look at this like 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2, like, and remember, doing, like, practicing that counting, looking at it in different ways like that can be very useful. Oh, and I should go back. 1, 2, 3, negative pi by 2. So I'm doing sine. I start on the 0 line for sine, and I start on the start. So negative pi by 6, which is negative 1. I haven't done my vertical. I'm going to do, I think I can count 2. So that would be 1, 2, 3, 4, and negative 2. It's got a reflection. So I'm going to count 6, 1, 2, 3, 4, 5, 6, and go down to the minimum. 1, 2, 3, 4, 5, 6. Back on the 0 line. Up to the max. 1, 2, 3, 4, 5, 6. Back to the 0 line. 1, 2, 3, 4, 5, 6. And I love this method because then you can check and make sure that that is, in fact, 23 pi by 6, which is a little bit nasty. But it is, because the next one would be 24 pi by 6, which is 4 pi. So we're all good. Oh, thank you. So my graph is going to end up looking wonky because I counted by 2 and then I didn't count by 2. Ooh, glad you caught that before I graphed too much. Whoops. 1, 2, 3, 4, 5, 6. So I should be right there. All right. Whoa. And there we go. Very quickly, if this was cosine and it was reflected in everything, cosine would start at the minimum then, and then it would go to the 0 line, then it would go to the max. Still, it would be, everything else would be the same though, right? Then back to the 0 line, then back down to the minimum. Something like that, if it were cosine. Any questions? Everybody good? Okay, I'm going to skip that question, move on to Unit 2. Oh, I meant to add in some extra space. This is really tight for space. Whoops. So this looks like the first question that we started with, but it's a Unit 2 question. Why is it a Unit 2 question? Because the special triangles don't have pi by 12s in them. So I can't do it that way. So how do you do it? We learned formula where you could add two angles together, and we have a formula for that. Sine of A plus B equals the whole big thing. Cos of A plus B, or A minus B, or sine of A minus B. So if I can get two angles that I can find the exact value of, just like we did in the last part, that add together to 17 pi by 12, then I can use my formula that's appropriate for that case to solve this. So it's quite a bit more work. And then you got to know, like, what are the angles that you're allowed to use that will work for this. But some people would do 10 pi by 12 plus 7 pi by 12. Well, how's that going to work? Because we can't find 10 pi by, we can't find 7 pi by 12. Like we can't, well, 10 pi by 12 maybe we can, but 7 pi by 12 we can't find. We're still stuck with the pi by 12. So you got to make sure that you are using the right kind of angles. And it's all the multiples of pi by 6, pi by 4, and pi by 3. So 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4, all of those ones, right? And in this case, I'm gonna say it's the sine of 9 pi by 12 plus 8 pi by 12. Nine pi by 12 is 3 pi over 4. 8 pi by 12 is 2 pi over 3. So I can do both of those. And now we have to remember the formula. They're all kind of similar, but obviously different in important ways. And now I got a whole bunch of work to do. In this case, you don't have to show as all the same steps as you did in the last unit. But you can imagine as a teacher, if I asked this question and a question like the one we're working on now, the point of this question would be that I see that you understand how to do it, like without your calculator, because you show me the steps and the relationships along the way. And then I use that to assume that you could also do it for this. So I let you get away with it here so long as you showed it to me in the other case, right? Like that's how a teacher might be trying to assess you. So 3 pi over 4 is in quadrant 2, where sine is positive. So it's equal to the sine of pi over 4, which is 1 over root 2. This is 1 over root 2. 2 pi over 3 is also in quadrant 2. The cosine of pi over 3, that's like the cosine of 60, which is a half, but it's negative, so times negative a half, plus cosine of 3 pi over 4, so that's negative again, so negative 1 over root 2. And then sine of 2 pi over 3 is positive again, and it's root 3 over 2. And then I'm going to simplify this, so that's negative 1 minus root 3 over 2 root 2. And if you have a calculator that can do that and give you an exact value of, you might get 1 mark for just putting the answer to a question. Again, there were 5 steps to that question to get to the answer. If you show 1, you get 1 mark. Maybe. Okay, I'm going to keep going because we got a couple more things to do. Ooh, 1, 2. Yeah. Oh, dear. That's how you solve the pi by 12s. How do you solve the pi by 8s? To solve the pi by 8, we use that was a compound angle formula, what we call a compound angle formula. For this one, we use a double angle formula. So in this case, again, there's a whole explanation to it, but we don't have time for that, unfortunately. So cos of 5 pi over 4 equals, and then you need the formula 2 cos of 5 pi over 8 cos squared of 5 pi over 8 minus 1 is the formula. Is a double angle formula. One of them, there's 3 for cosine. But we always use those for this process. Even if I'm looking for sine, we can't use the double angle formula for sine. If you look back at what they are and you think about it, you can probably see why. So I got to do a couple of things. I have to evaluate cos of 5 pi over 4. I can evaluate that and then rearrange this whole equation to solve for so that it says cos of 5 pi over 8 equals. And then I've got the value of that. That's how we do this. So the cos of 5 pi over 4, that's in quadrant 3. I'm past 4 pi over 4, 1 past that. So that's negative. And cos of pi over 4 is 1 over root 2. So this is equal to negative 1 over root 2. I'm going to bring the negative 1 over. So plus 1. And then I'm going to divide the whole thing by 2. And I'm going to stop there, equals cos squared 5 pi over 8. So I moved the negative 1 and the 2 over to the other side. You could do a common denominator here and have that as root 2 over root 2. That's going to make it look a little bit nicer. But you don't have to. Then I'm going to take the square root. And what do we need to think of when we take the square root of something? There's a plus and a minus, but cos of 5 pi over 8 is either positive or negative. That's something we can determine. 4 pi over 8 is pi over 2. So 5 pi over 8 is a little bit more. So I'm in quadrant 2 where cosine is negative. So this is not plus or minus. It's just negative of that. And that's the last little step to this process, is realizing that we actually know the sign of that. You could also check it on your calculator. You could type cos of 5 pi over 8 on your calculator. It'll give you negative some nasty decimal. So you know it's negative, but we can figure it out with CAST. Any questions? I'm going to stop there. We'll do the identity, and there's an equation to solve, a couple other little things. We'll do those tomorrow, and we'll do Unit 3. There's not a lot to Unit 3, so not as much review.